So for this trig one, and I threw this on here because I saw one on AP Classroom like this, you do need to remember one identity from pre-calc. So I'm going to write the identity off to the side here and see if you guys remember it. Sine squared equals, okay, is that one that was like a more easy to remember one? Okay, I know there were a ton of really strange, weird ones. That one's not usually so bad because it comes from the Pythagorean theorem, right? So when you look at this limit, and just go ahead and write limit x goes to 0, what can you replace that 1 minus cosine squared with? It would be sine squared, because if you subtract this over 1 minus cosine squared is going to be sine squared. And then I have one more step to show you how it turns out. So I'm sorry, but write limit again. Sine squared, and that 5 is still there. Sine squared means sine times sine. And I call it a twin. Like you see the squared, that means you have 2 of them. And same thing in the denominator, x squared would be x times x. So, okay, is that ringing? Are we finally seeing like ringing a bell there? So do you remember circling these? Sine of x over x is going to go to 1. That part will be 1. This part will be 1. So then your answer is just 5. No, it's not. The answer, like whenever we finish a problem, the takeaway is always, oh, that's not so bad. It just looks really scary. They intimidate you on purpose to make you think it's really awful. So I'm just going to be super transparent with you. All of those translate to multiple choice questions. This is where the free response starts. Okay, so this is where you have to be really sincere with your notation and everything, because up till now, the work's not going to get graded. It doesn't matter. Here's where you really have to write every last little nitpicky thing. Okay. So for what value of k is the function continuous at 3? Definition of continuity. You need a point, you need a limit, and then we're going to set them equal. Okay, so f of 3. Which piece of the function does 3 belong in? And I'm looking for like the first, second, third, or fourth. Third. Do you see how the equal to is on the 3? Yeah. Okay, so if we plug 3 into that, what do you get back out? 16. So the actual point is at 3, 16. So that's our point. Now, when you do the limits for a piecewise function, you have to do from the left and from the right. So we're going to do limit x goes to 3 from the left, and you just have to make a decision, which I get is hard. From the left would be that third piece. Do you see that? Okay. Thank you for heads nodding. So that's the 2x plus 10. Limit x goes to 3 from the right would be that awful thing. Okay, but just recopy it and just try not to do a copy error because those are the worst. And just remember what they are trying to do is intimidate you. You can't let them do that. Remember that basically you're just going to plug in 3 and you know how to do that. They're making it look scary. Okay. You need to not allow them to intimidate you. So we're going to plug in 3 to this, and we're going to plug in 3 to this. We really already did this one. It comes out to 16. All right, this is the messier one, but just stay calm. We'll get through it. Let's plug in 3. 3 squared. 9 times 2, 18, plus 7. 25 minus 3k. We don't know what k is. That's actually what we're trying to find. K is your goal. All right, and then plugging 3 in down here. 3 squared, 9, plus 6, 15, minus 5 is 10. So we have the point, we have the limits from each side. What you want to do is set them equal. So you're going to take this 25 minus 3k over 10 and set it equal to 16. And then do the algebra, whatever you get is your answer. So what would you do to like start? Multiply by 10. So 25 minus 3k equals 160. Don't worry about that. That's just what it came out to. Subtract 25, 135, and then just divide it by -3. For free response, I don't think we've had an opportunity to talk about this yet. You don't have to simplify anything. Once you get it down to a value, you walk away. And you're better off not, for two reasons. Number one, if you mess it up, it's gonna be wrong. And number two, the exam is timed. So don't simplify anything. All right, B, find all the horizontal asymptotes. You have to look as you go to negative infinity, and you have to look as you go to positive infinity. So we're gonna do limit x goes to negative infinity. Now look back up, which piece of the function would you use to go to negative infinity? Yeah, the first one. I know that looks scary. We'll talk about that in a quick second. And then limit as x goes to positive infinity, which piece of the function are you going to use? Yeah, the last one, that like horrible looking one. They won't. Can you hold on a second? Because I wrote that quickly and let everybody write it. Do you remember how I said if you're going to positive infinity, it's super, super important. If you go to negative infinity, it's not important. If you draw the exponential graph like this, where is it headed as you go to negative infinity? Zero. It's leveling off at zero. So as you go to negative infinity, this part's going to go to zero. And then down here, you would have 3 minus 0. It's insignificant. It goes to nothing. And 0 divided by anything is 0. So that horizontal asymptote is y equals 0. That's one of them. And then for this one, who's in charge? Well, you have a 2x squared and a 1x squared. So that's going to level off where? 2. And so your other one is y equals 2. Those are your two answers. So when you want horizontal asymptotes, you're doing the limits to positive and negative infinity. For the sake of being thorough, wink, wink, nudge, nudge. Instead of negative infinity, let's pretend that was positive infinity. Because it's like that on your test. When you're looking at who's in charge, you have the 10e to the x and the negative 2e to the x. Those are the same as far as who's in charge here. So when it's the same, you use what? Coefficients. So 10 over negative 2 would be negative 5. Okay, just for the sake of being fair. But if it goes to negative infinity, it's going to be 0. All right, what type? Yeah, like put circles around that because I'm trying as hard as I can to like tell you exactly how it is on your test. All right, what type of discontinuity do we have at 0? Well, let's look at our limits. X goes to 0 from the left and limit x goes to 0 from the right. You have to look at your limits from both sides to figure out what on earth is going on. And we're doing good. I think I will be able to finish this before we leave. You just have to stick with me. So 0 from the left, which piece of the function are you going to use? First one, 10e to the x over 3 minus 2e to the x. You just have to do decision making, which I know is hard. And essentially, you're just going to plug in 0. Remember that the math you're doing is not difficult, right? If you plug in 0, ooh, what's e to the 0? 1. Anything to the 0 power is 1. So your numerator is 10, and your denominator is 3 minus 2, which is 1, so 10. Which piece of the function will you use for 0 from the right? The 2x plus 10? You seen that? Okay. I know we're all tired. I'm hungry. 2x plus 10. If you plug in 0 to that, it's 10. Oh my gosh. The left went to 10 and the right went to 10. That means we have a limit, both sides going to 10. With me? Yes. Okay. Now we need the actual point at 0. So look back at the piecewise function. Where's the actual point when x equals 0? 4. So think about visually what that would look like. The limits go to 10, but the actual point's at 4. It's that like floating point. Do you get what I'm saying? What type of discontinuity is that? All right, removable discontinuity, and you can abbreviate for me. I don't care. Removable discontinuity at x equals 4 because, oh wait, it wasn't x equals 4. That happens all the time though, so I'm glad I'm showing you that. That would be wrong. Why is that wrong? It's x equals 0. Whew, crisis averted. Removable discontinuity at x equals 0 because limit as x approaches 0 of the function doesn't equal f of 0. Do you need to sneeze? Tricks you. Hanging in there? It won't be as hard when like most of the test is multiple choice. Okay. Usually you can narrow it down to 50. All right, so the amount of money that's raised during fundraising is given by that awful function. Find limit as t goes to infinity. All right, that would be limit as t goes to infinity of which piece of the function? First one or the second one? The second one, okay? The uglier one, yes, I agree with you on that. So infinity is who's in charge here? Who's in charge of the numerator? 800t. Who's in charge of the denominator? T. What does that mean? It's just going to be 800. Now, I think doesn't it say explain what it means? Okay. That means as time goes by, so as time goes by, or you could say as time increases, what is true about the money raised? Because remember, it was about fundraising. Let's talk it out and then we'll find a short, like a succinct way to write it. As time goes by, what's true about the money you're raising? It'll go towards 800, but never reach or exceed 800. Okay, so whatever's like the most succinct way you can put that. As time goes by, money raised will approach, but not exceed $800 or something like that, something to that effect. As time increases forever and ever, you're not going to be able to raise more than $800. Oh, jeez. It just means maybe you're selling candy bars and you saturated the market with candy bars, so no one's buying any more candy bars. You know what I mean? All right, and then is the function continuous? Oh my gosh, what are the 3 rules for continuity? There's a point, there's a limit, they agree. Okay, so we're gonna find f of 7. Which piece does 7 belong to? The ugly one, good, okay. 7 times 800, we're just gonna plug it in. That'd be 5,600, like 7 times 8 is 56, it's just hundreds. Minus 4,800 over 7 minus 4. So let's see. What is that? 800 over 3. Cool, leave it. You don't have to simplify anything. That's it. Well, we found a point. Now we need to do our limits. Limit from the left, limit from the right. So from the left, you're going to use the first piece. And from the right, you're going to use the ugly one. Like how you guys called it the ugly one. But remember, pep talk, because I know we're getting super tired. The math you're doing is just plug in 7 and you already did one of them. Which one did we already do? Yep, this one is gonna equal 830. You already did it. Okay, so you can't let them intimidate you. I can't change this material, but I will be as much of a cheerleader as I can be. I can't change this, but I'm going to support you as much as I can. All right, now this one, when you plug in 7, you're going to love this. 7 plus 1, 8. So you get 2 to the 8th minus 2. And I really don't care what that is. The point is, it's not that. And you don't have to simplify it, okay? So big overall answer. Is the function continuous at 7? No, not continuous, you can abbreviate, at x equals 7 because, and the reason why is what happened with our limits from the left and right. You're going to throw that like no parking sign in between them that they aren't equal. Limit as x goes to 7 from the left of the function doesn't equal limit as x goes to 7 from the right of the function. Hey, Ms. Cole, what if I put a lowercase f? Full credit. They'll give you that. I just put capital because that's what it was in the problem. I have 9 minutes. We can do this. I want to finish this so we can just be done when we come back. You really hope what?
I really hope there's so much 7, but like only 7 is not like this because like how I draw like the error.
Oh, like it runs into your 7?
Yeah, it looks like
I get you. And I always hate when there's like a 8 and an infinity in the same problem, like that same thing happens. All right. Let h equal g of f. Find the limit as x goes to 3. I told you there was going to be another one of these on here. You have to do from the left and from the right. So limit as x goes to 3 from the left. Limit as x goes to 3 from the right of g of f of x. I don't like how they make you write this one because you can actually get the answer without writing anything down. Like you could just write numerically an answer, but they won't give you credit unless you write all your limits. So again, when it's multiple choice, you can just figure it out and choose A, B, C, D. When it's free response is when you have to write all this stuff out. Like here, watch me point to it. Would you start with G or would you start with F? Which one's the inside one? F. Just watch me point to this and don't look away. We're going to 3. From both sides, what value gets approached? 2, from above sea level or from below sea level? From above. So you would need to approach 2 from the right. When you come over here and you approach 2 from the right, your answer is, the answer is just 4. And you can get that without writing anything down just by looking at the graphs, but we have to write this, okay? So anyway, when you approach 3, for x, your y value is 2. So we're going to do limit as x approaches 2. And it was from above sea level. So you have to put the little plus in there. And then you're looking at the outside function. And we just said 2 from the right goes to 4. And then this one's going to come out to literally the exact same thing because both sides of this are doing the same thing. So limit x goes to 2 from the positive side. It was from above g of x, and that equals 4. And so your answer is 4, but you have to write all that. I'm sorry, but I am the messenger on that one. I feel like you can get 4 without doing any work. You should be allowed to just write 4, but if you do that, that's what's called a bald answer, and they give nothing for that. All right, part B. Let k of x equal this thing. That's not too bad. Consider 2 and consider 4. At which one of these is there a jump? I'm going to talk you through 2. We're not even going to write anything for 2. Can you just watch? If you do 2 for f of x, here's 2. What is the value being approached? 4. You would end up with 4 minus 4, which is 0. Does it matter what g of x is at that point? No, because 0 times anything is 0. And so both sides are going to be 0 and it matches up. There's not going to be a jump. It says at what value is there a jump? So it can't be that one. All right, so we're going to look at 4. So limit x goes to 4 from the left, limit x goes to 4 from the right.
One or the other, right?
Yeah, like they're basically making it a multiple choice. We have 5 minutes, we will finish, I promise. And what was the function called? K of X. So let's do these from the left. Watch me point to them. We're gonna do f of x, 4 from the left. So here's 4. Actually, it doesn't matter if it's from the left or right. What gets approached? Do you see how that's 3 there? Okay, so we'll have 4 minus 3. It was 4 minus f of x, so it'll be 4 minus 3, and then times g of x. So do 4 from the left of g of x. Here's 4. From the left, it would be 1. So what is that total result? 1. Good. Now we're going to do from the right. F of x comes out to 3. It doesn't matter. Both sides went to 3. So you got 4 minus 3. What is g of x for from the right this time? Because that's different. 4 from the right is 4. So that comes out to 4. So your big conclusion, it said, at which value is there a jump discontinuity? So we're going to say jump discontinuity, you can abbreviate, at x equals 4, because, and what's our reason why? Like, why are we saying there's a jump? They're different. So it's the no parking thing. Okay. So limit as x approaches 4 from the left. Wait, I almost wrote f of x. It's not f, it's k of x. Doesn't equal limit as x goes to 4 from the right of k of x. And there's one other thing. They can be different and it still wouldn't be a jump. Do you see how one could be this and one could be this? Yeah. That's not a jump. Okay, if they come out to infinity, you don't have a jump. So you have to say neither is infinity. Oops, I didn't put the R on either. Neither is infinity. Because like these don't equal each other. So saying they're not equal is not sufficient to say there's a jump. It's sufficient to say there's something going on there, but not a jump. All right, last one. Values of f of x selected are in a table. What type of discontinuity does f have at 1? So we can see it's undefined. It's going to be discontinuous. Based on the values in the table, what is a reasonable estimate? So we're looking for removable or non-removable here. So what do you think? As we approach 1, what's happening with these values?
They're going to 3.
They're going to something around 2.7, but the point is, are they headed the same place? Yes. So both sides are headed to the same place, but we've got a hole there. So what type of discontinuity? Removable. So we're going to say removable discontinuity at x equals 1. And it says, what's a reasonable estimate for the limit? So limit as x goes to 1 for this function is approximately, and you would want to put what's halfway between these. So it's going to be 2.7. What's halfway between 84 and 87? Be 86, right? 6, yeah, 86. So 2.786, because it is between 2.784 and 2.787.